Welcome back, Warhawks, to a thrilling edition of Carnegie Math here at Seminole High School. Today we're going to be learning how to find the area and perimeter of parallelograms. Parallelograms are four-sided figures where opposite sides are congruent and they are parallel to each other. You're probably familiar with a couple. A square is technically a parallelogram. A rectangle is technically a parallelogram. But when we see them, they're going to be more recognizable as parallelograms, which you'll see in just a second. They have a couple different features that usually has them being described as parallelograms. So our goals today are we're going to use the distance formula to find the perimeter. Perimeter should be no problem at this point. We've found the length of sides by either counting or using Pythagorean theorem distance formula. That should be easy. Today we're mainly concerned with finding the area of these parallelograms. So typically this is what a parallelogram looks like. When you're going to classify it as a parallelogram. If it's a rectangle, you usually say a rectangle. If it's a square, you usually say a square. But here we have two sides that are opposite of each other that are parallel. They're also congruent. And we have these two sides here that are opposite each other that are also parallel and congruent. If you notice here, if we're trying to find the perimeter, which we can do real quickly, we just want to count. So when I count this length, because it's actually on a line, I get, okay, 1, 2, 3, 4, 5, 6, 7, 8. So that length is going to be, 8. And this length will also be 8 because it's a parallelogram. Opposite sides are congruent. Now, for this length, it's diagonal, so we're actually going to have to use the Pythagorean theorem or distance formula to kind of make that triangle in there. But you go from -7 to 5 is 2, so we're going to do 2 squared. That'd be this distance right here. And then from 1 to 4 is going to be 3, so we do 3 squared, and then we're going to be able to find the length of that side. Okay, I went ahead and did the calculations. We got 2 squared was 4, 3 squared was 9, added them together, 13, take the square root, and we get that this side is 3.6. If we look over here at this side, is also going to be 3.6. So now we just add those together and we'll get the perimeter. So here I went ahead and did the perimeter. It equals 8 plus 8 plus 3.6 plus 3.6. Gives us a perimeter of 23 units. Now let's go ahead and find the area of this shape. Well, I'm going to erase a couple things here. I'm going to erase this, this, and this, and this, and I'm going to redraw that. But for area of a parallelogram, the formula for area is going to be the same thing as it is for a rectangle, just base times height. Now, we've talked about when we're finding a base and a height, we need a right angle. I don't see a right angle here, but the nice thing is, because these are on the X lines, we can just draw down a line and create a right angle. And actually, it's going to be easy to find the height of this shape because we just count. 1, 2, 3 is going to be the height. Now, let me show you why this works out. If you can imagine this parallelogram, look at this triangle over here. If I went ahead and cut this triangle out right there and I pasted it over here, look what kind of shape we would have. If I would just forget about this part, you would actually create a rectangle. So that's why the formula is the same. It's just the base times the height, and we get the formula for the area of a parallelogram. So our area is going to equal 8 times 3, which gives us an area of 24 units squared. Area is always measured in square units. Okay? Let's go ahead and look at another example here. This parallelogram looks a little bit different. There's 2 sides that we can find the length of just by counting. So I'm going to go ahead and do that. This is 1, 2, 3, 4, 5 units long. So we put a 5 there. This one is also 5 units long. So we go ahead and find the area. Actually, it's easier to find the area first because now we need a 90-degree angle. But look, I'm not going to be drawing one down because these 2 lines are not on an X line or a Y line. The ones that are marked 5 happen to be on Y lines, so I can just draw in the height, make it a 90-degree angle. It goes right along there. They intersect at 90, and then I can just count 1, 2, 3. It's going to be the area or the height of that. So now I just do a base. Where's that 90-degree angle? Right there. Base times height gives me the area. So 5 times 3, and the area ends up equaling 15 square units. Just a different way to write square units. So there you go. Now if we want to find the perimeter of this shape, we don't really need this stuff here, but what we can do is we can find out the length of this side. So I went ahead and found out where those points are located. This point's located at 2,6. This one's located at 5,8. Now I just need to find the length. I'll make it a Pythagorean, just draw in that triangle there. The distance from 2 to 5 is going to be 3. The distance from 6 to 8 is going to be 2. So we go ahead and we square those. We get 9 plus 4. And actually, we've already seen this answer on the last question. We end up with 13 equals c squared. And then we just take the square root of 13, which ends up being 3.6. So that side, again, is going to equal 3.6, which means this one also equals 3.6. And now we can find the perimeter. So I just went ahead and did the math. 3.6 plus 3.6 plus 5 plus 5 equals 17.6 units. That's going to be the perimeter of this shape. Remember, again, that height right there was 3, which enabled us to find the area. Okay, now we get to a tougher question. I'm not really going to worry about the perimeter right now. We can find the perimeter of this shape. I feel confident that you all can do that. You would just use the distance formula to find the length of 2 of the sides, and you only need to find 2 because the opposite sides are going to be the same. But right now we're going to be concerned with finding the area. There's a couple different ways we could find the area of this parallelogram. You may notice that neither one of the sides are on the y lines and neither one's on the x or y lines. So look, we can't just count any of the lengths of these sides. There's a couple different ways we could do this, and I've thought about it and tried to turn it into the easiest way that we can do this. Some of you may notice that we have 2 triangles here. You could find the area of that triangle and you could find the area of that triangle, and you could add them together. But I feel like there's another way that we can do it that's going to be more consistent, because not always will the area of the triangles be so easy to find. So let me change the color of my line here. I'm going to show you what I want you to do on these questions. So what I'm going to do is essentially turn this picture into a rectangle. Okay, you can see that I drew a rectangle actually around the parallelogram. The nice thing here is that it's very easy to find the area of a rectangle. So I'm going to go ahead and do that first. The rectangle's area is going to be the base times the height. Here we have a 90-degree angle, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be our height. So 8. And the length of the base is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of that whole rectangle is going to be 96. So we'll keep that in the back of our mind for just a second here. I'll just write that that's the rectangle. Now, something you may notice about this picture is we have triangles right here, which are actually going to be easy to find the area of. Look, this is a right triangle. We already have a base and a height for this triangle. So 1, 2, 3, 4, 5, 6, 1, 2. There's our base and our height of that triangle. So for the triangle, we just do base times height, 6 times 2, divided by 2, and we get that the area of that triangle is 6. So this had an area of 6. Well, guess what? We have another identical triangle over here that also has an area of 6. Now we just need to find the area of these 2 triangles. So let's see what the base and height are. Again, there's a right angle right there. So we do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now we can just do for this triangle, we're going to do 6 times 6, area of a triangle, divided by 2. 6 times 6 is 36, divided by 2, don't forget to do that, is 18. So the area here is 18, and the area down here is 18. Now you're asking yourself, why are we doing this? Well, look, the whole area of this rectangle is 96. We don't want the whole thing, though. We just want this part right here that's the parallelogram. But I found the area of the stuff we don't need very easily. All I have to do is subtract out these numbers from the area of that whole rectangle, and then I'm just left with this part in the middle. So let's do that. 96, we're going to subtract 18, another 18, another 6, and another 6 from 96, and we'll end up with our area. Let's see what that is real quick. So 96 minus 18 minus 18 minus 6 minus 6 gives us an area that's left over of 48 units squared for this parallelogram. Okay, that's a tough question. We'll work more on those in class, but write that down in your notes and you'll have an example there. But that is a hard question. Hope you all have a good weekend, and we'll see you on Monday.